Let's look at how we can answer this SUVAT equation. So first of all, let's see how we identify it as a SUVAT problem. A stone is thrown up at 15 metres per second from the top of a cliff 40 metres above the ground. Find its maximum height above the ground. Find its speed as it hits the ground. Find the time taken to hit the ground. So, I know this is a SUVAT equation problem as there is a constant acceleration. The only force acting on this stone will be gravity, and therefore gravity is constant. Okay, therefore it's a SUVAT equation. So, remembering we can only use SUVAT when we have constant acceleration. Let's think what information we're given, and let's try and sketch it. If you get a sketch, you'll often find these questions are much easier to understand. So, we've got a cliff. Let's draw a very simple cliff. And a stone is thrown up at 15 metres per second. And I want to find its maximum height, that point there. And then I also want to know when does it hit the floor. Cool. So we've been given our initial speed. Let's write that down. So whenever you're doing a SUVAT question, I would always recommend start with listing the information you know. So initially I want to find its maximum height above the ground. S is what I want to know, so I'm going to put a little question mark there because that's the question. U is 15. V, we don't know that, so I'll leave that blank for now. Acceleration, we will take it as given that acceleration due to gravity in a maths exam is 9.8 metres per second squared. Okay, we don't usually bother with units here because this is just our workings. We can put units in at the very end, but 9.8 metres per second. If you do physics, you may take this as 9.81. I would recommend use 9.8 in maths. We're ignoring things like air resistance, size of the stone and things like that anyway. So three significant figures is probably a little bit too accurate anyway. And then finally time. Again, we don't know time at this point. So let's have a read of the question, see if there's anything else we can discern. The first part says, find its maximum height above the ground. So if we think about this, at the moment it doesn't appear we have enough information. We need 3 bits of information in order to find a fourth. We appear to only have 2. So let's look at this, and at this point here, its maximum point, as we're only considering its vertical motion, at its highest point, it must be stationary. It's no longer moving up, but as yet it hasn't started moving down. So that actually, in a coded way, tells us that its final velocity for this first part of the question is 0. One other thing that I need to consider is that my acceleration will be negative. Remember, everything has a direction. I'm going to take upwards as positive and downwards as negative. Before you do any kind of SUVAT question, you should always consider which direction you're taking as positive and which as negative, and then just make sure that all of your values, as these are vectors, are going in the correct direction. Up, positive, down, negative is what I've decided in this case, and as it's accelerating downwards, acceleration will be negative. Okay, so I've got my equation. I've got my set of information, I can now think what equations should I use. Looking at my equations, there is one equation which doesn't involve t, and that was u squared plus 2as is equal to v squared. I know u, a, s and v. So this just tells me that 15 squared is equal to minus 2 times minus 9.8 s. Remember, v was 0 and acceleration is negative. If you ever find you're having problems with this, you've probably got some of your signs wrong. Have a look at your sketch and consider whether your signs are correct. So let's just put that into the calculator. So we've got 15 squared. And then we want to divide that by 19.6. That gives us a displacement of 11.48 meters. So that is the distance it will travel there, a displacement of 11.48 metres. However, I must take into account this 40 metres here, as the question asked me find its maximum height above the ground. So max height will be 51.48 metres. Always make sure that you answer the question. Little things like, rather than finding its displacement from where it was thrown, finding its maximum height can lose you a mark quite easily in the exam. Okay, now let's move on. The next part of our question said, find its speed as it hits the ground. What I would recommend is, as soon as your situation changes, rewrite out your SUVAT information. Oops. I like to just do a column, some people like to do a table. Format is entirely up to you. So as it hits the ground, again, its speed when it hits the ground, or velocity when it hits the ground, sorry, is what I want to know. I know it was thrown at 15 metres per second. Again, don't worry about units here. And its displacement, I know that will be negative 40. Looking at my sketch, it will have moved down 40 metres. Acceleration is minus 9.8. Time, I don't really care about. So now we want to find our velocity. It will be the same equation, the one which does not involve t. However, this time I'll be solving for v. So I have the u squared plus 2as times 9.8 times 40. They're both negative, but then my negatives will cancel out. And that's going to equal velocity squared. U was 15. So let's type all that into the calculator again. So we're going to get 15 squared. Let's just put it in scientific mode. Plus 2 times 9.8 times 40. And then we square root our answer. Oops. Square root of 1009. V is equal to plus or minus, because we've done the square rooting, 31.76. We will actually want the negative value here as it is moving down. So our velocity is negative 31.76. However, the question asks us for the speed. Remember, speed is scalar, 31.76 meters per second. Okay, so when we've got a new situation, we rewrote out our SUVAT information. And importantly, and a mistake that students often make, we didn't care that it stopped temporarily at the top there. It still kept the same acceleration. We only have to break our model and then draw out a whole new model if acceleration changes at some point. As it was, the model didn't change when it reached its highest point, so I just kept initial speed 15, displacement minus 40, acceleration minus 9.8, and we didn't care about time. And now finally, find the time taken to hit the ground. So we have that as 31.76. I now want to know my time. I could use my velocity that I've just calculated. However, if you have the choice, it is more reliable to not use that. Maybe we've made a calculation error there. So let's choose the one which doesn't involve v. S equals ut plus half at squared minus 40 is equal to 15t minus 4.9 t squared. Let's rearrange this and we will get a quadratic. So remember, always make your quadratic term positive. 4.9 t squared minus 15t minus 40 is equal to 0. And now I'm just going to solve that quickly. So we'll have quadratic formula on this one. You would probably just put it in your calculator. T is equal to 15 plus or minus the square root of 15 squared minus 4 times 4.9 times 40 minus 40 all over 2 times that is 9.8. So plugging that in gives us 4.772. That's probably too accurate, 4.77 seconds. I've only considered the positive root here. If we consider our sketch again, there will be two solutions. The negative one will be if our model continued and it had been thrown from the ground initially. That will tell us how long before it was at this point here would it have been at the ground. However, that doesn't make any sense, so we're going to ignore that solution, just take the positive root, and that gives us time of 4.77 seconds. That's how long the stone will take to hit the floor.